chapter 18. The problem starts from 29. It says a particle travels at a constant velocity of 3 meter per second. Then it stops for 10 seconds before completing its journey in another 30 seconds with 2 meter per second velocity. So to find V average for whole journey. Okay, this is the requirement. So he has gone, let's say it's gone from A to B with in 20 seconds velocity 3 meter second. Okay. Yes, 3 meter per second for 20 seconds. So this is gone for 20 seconds, 3 meter per second. Then give a halt. Then move forward to other distance C. So this case it is 30 second, 2 meter per second. So that problem is just similar to the earlier problem. Only thing is that he has given a halt of 10 seconds. So how will you use that time? For any halt in between any motion, okay, that also to be calculated for their velocity average or the speed average, that you keep in mind. Even though it is not moved any distance, but that is being utilized in between the travel, so that has to be included in total time. So your V average must be the total distance is 20 second into 3 plus 30 second into 2. That will be the total distance, but and time is 20 seconds for the first journey, 10 seconds for the halt, and 30 seconds for the second journey. This will be the V average. In case it is speed, so that also consider the total time. Okay, the total time, you need not worry about that. Whatever time it is utilized during the motion, which will be a part of the journey, that you can assume. Okay, so this will be 60, that means 2 meter per second will be the average velocity. Okay, moving to next. Number 30. Number 30 says a body moves with a velocity of 3 meter per second due east, and then turns due north to travel with the same velocity, if the total time of travel, if the total time of travel is 6 seconds, then find acceleration. Okay, so this is the problem. Now, as you know, the directions are understood by upwards north, this is east, this is west, and this is south. Now the body is moving with the velocity 3 meter per second eastwise. So this is moving with the eastwise at 3 meter per second initially, and then turns to north. From somewhere it is reaching, let's say from O to A has reached, then after turns north. Okay, this was north with the same velocity 3 meter per second. Okay, the same velocity. Now we have to calculate the acceleration for it. So as you can see, these vectors are going eastwise first, then northwise. So acceleration is what? Acceleration is the change of velocity, that means final velocity, the initial velocity upon time, isn't it? So this one, if I say what is that mean actually, if I say, or you can say the v2 minus v1, I am taking it v2 minus v1, not initial velocity. So that velocity that going to the east, this is the start of the journey, it is going towards east with the velocity v1, then after move to v1 to v2. Apparently seeing these are of what? Same quantity, so it is deducting, but vector cannot be added numerically, algebraically. So these are some different meaning. What is that acceleration is? So this can be written, if I turn this into a into t, must only I have to consider v2 minus v1. What is that? So this can be written v2 plus of minus v1. So this is the addition of some two vectors v2 and v1. This minus denotes the opposite direction. That means if v1 is the initial velocity, this is toward this, so the equivalent velocity which is upward will be degraded this. So this is, if this is let's say v1, so this opposite direction will be minus v1. Okay, now if we assume this, if two vectors is this, now this vector can be shifted here, this vector parallelly shifted here, I am shifting here, so this is v2. So now the vectors which are, now this can be shifted to this one also. Okay, so this is your minus v1 actually, this is your v2. So what is the resultant for that? If I take the resultant, so let me see it like that. I don't want to shift it, so it will be, because that formula I am not taught you, the summation of vectors, but that one thing I have taught you, that is the two vectors, if it is consecutively moving in the same clockwise direction, let's say, so that the resultant must be forming a triangle and which will be in the opposite direction. So that means if it is v1, this is v2, so this is resultant, that means the resultant between the v1 v2, and this is minus v1. So this is, so actually this is some vector that can be denoted as, let's say I am again assuming v3 is equivalent to minus v1, so I can name it minus v1 as v3. So this is one vector, this is another vector with directing clockwise, the anti-clockwise, this will be the resultant. So this is nothing but the resultant of this. Okay, now if I assume this is equal to what is a acceleration, that v2 minus v1 by t. Okay, so actually the acceleration is also can be written as v2 minus plus or minus v1, that I have seen. So that minus v1 is that the actual v1 is this east side, that will be west side. Okay, so west side some vector with a vector this will give you resultant this. So ultimately the acceleration will be on the direction of resultant vector. The cumulative action of these two vectors together, it will give you a resultant vector this way. So this is the actual change of velocity. So what is that? If we see the triangle, it is a right angle triangle. So resultant is, if I take the value magnitude of the resultant, it will be this square plus this square. This is definitely r. The resultant r, if I say, will be the square root v1 square plus v2 square. Okay, so this is equal to under root of 3 square plus 3 square, that means 3 root 2. The velocity will be 3 root 2. The resultant is 3 root 2, and with that velocity, it has, although it has moved from this direction to this direction, the total time will also be considered for the acceleration, because acceleration is nothing but the change in velocity. Velocity depends on the displacement. So as this is the shortest distance moved in this direction, as you can assume the resultant velocity and that same direction. So the resultant velocity, the magnitude of resultant velocity is 3 root 2. So this is the value of it, resultant velocity. There is ultimate this is giving the resultant velocity v2 plus or minus v3. Okay, so acceleration is what? The magnitude of acceleration, if I say, so this will be the magnitude. Ultimately v2 plus minus v is equal to 3 root 2, and your time is, you have to take the time, because that will come under mod. These all are vectors. But what is the magnitude of acceleration? It will be the resultant velocity, magnitude of that by the time, that will be 1 by root 2. So the magnitude of the acceleration will be 1 by root 2, and that will be in some direction this way. This is what? Because this is equal vector, so this must be 45 degree. The angle forming with the x-axis is 45 degree this way. So this is what? The positive x-axis is 135. So 135, any angle, if I shift it from the origin, this will something which will give the northwest direction. So 1 root 2 towards northeast direction will be the acceleration, the direction of that. So if the total time travel is there, then find acceleration. So acceleration, if I say 1 by root 2, but the direction is northwest, because that will divide it into 45 degree. So as I know, the 40, if it is something angle making the 45 degree with the axis, so this will nothing to say differently. Rather, we can say this is northwest directions. That I have already learned in the theory sections. So I think you can understand. So what I did, this is the component of velocity, first eastwise, this is northwise, then moved. So then that is the difference. The acceleration is the difference of velocity by time. Differential velocity I am writing as v2 plus minus of v1. So minus 1 v1 is that. So this is the total sum of two velocity. So minus of v1 nothing but this velocity, which is v1 on the eastwise. So the opposite will be the minus v1 on the opposite westwise. So now see, two vectors are moving in the clockwise direction. So if I join the open end of the triangle, so that will denote the resultant, and that direction will be anti-clockwise. So now the value will be, as because it is 90 degree triangle, so the resultant will be v1 plus v0 whole square. So this is 3 root 2 the magnitude, and the direction, if I move this parallel vector this side from the origin, so that will form a 135 degree definitely, because these vectors are equal. So this will make a angle 45 degree definitely. So this will give you northeast direction. So moving to the next problem. For a body moving with a uniform acceleration, for a body moving with uniform acceleration, a initial and final velocities in a time interval t are u and v respectively. Then its average velocities in the interval of t. Then average velocities v average in same time t. Okay. So v average is in time t. So what is the v average? We know v average is the v plus u by 2, the change in velocity by the sum of the changing velocity by 2 is v average. How you can say that? Because we have seen if the constant acceleration line against when v against t is this one. So if I take any two segment where initial velocity u and the final velocity v, so to find the the distance traveled, if I calculate, it is the area between the this you can say trapezoid. So this is what is what half into this is we get as half into this plus this parallel sides sum into the time t. So here you can see this is average velocity v plus u by t. You can say this is average velocity to time, that you can say by v average into time. From there I got the relation. Okay, second equation of motion I've got from it. So that says v average into time. So that is graphically also proven, or even you can say if the v mean you can take, so with that velocity that time if it is, so whatever I will get the v mean, so that will give you the same result if I calculate the area. That area denotes the displacement. So v average is v plus u by 2. Okay, that also same way utilize there. So v is equal to again with the from the first law of equation u plus at, it is a constant like acceleration for time t. Now if I put the value of u here, so you can put the value of v directly. So what you get if you put in terms of u plus at plus u, that will give you 2u means u plus half at. That would be the one condition. Or you can put in terms of v also, whatever the choice been given. If it is given that, so in that case u is equal to v minus at in terms of v, so then also v is equal to u is equal to, you can say, v minus at by 2. So that can be said as half at v minus. So any such any two equation, any of the equation can be u plus half at or v minus u at, anything which is given in the option, you can choose and accordingly you can answer it. Okay. The Question number 32. A bullet traveling horizontally okay, loses 1/20 its velocity while firing a wooden plank. Then the number of such planks required to stop the bullet So how many such planks are required to stop the bullet? So one bullet is being fired, that is moving with the, now it is passes through some plank. Let's say the plank of, this is the width of the plank. Okay, now when it is touch the plank, it has velocity, let's say v. When it is leaving it, it is v minus v by 20. It is loses 1/20th time velocity passing the whole plank. The number of, so this is the reduction for one plank which is having width of this. So during covering this displacement, it loses the velocity. So what will be the deceleration in this case? So you have to calculate deceleration. So that means you have to calculate. So the relation for acceleration when v, the final velocity minus initial velocity by time is not given, but it is a relation with the s, where to that the third law of third equation of motion can be used, 2as a, where s is equal to width of that, or you can consider s. This is arbitrary, so you can consider s also, no need to change the letter. So a you have to calculate, but here the thing is retarding, so that means the equation will turn, because those are vectors, so turn into 2as, as because this is reducing, so v is less than u. So what is v here? This is v by 19 by 20 v. So this will be 19 by 20 v whole square, and u will be the v square is equal to 2as. So here if I say what is 2as, equal to v square minus 90 square by 20 square into v square. Okay, now v if I take common, it will be 20 square by 90 square, the 20 plus 19 is equal to 39, minus is equal to that will give you, so that will equal to 20 square. So this is the case when a retardation A is given as 1 by 2s into 39 by 400. Okay, this will be the case. Now A is known. Now what would be the ultimate case, where I have to find the number of planks. So one plank, if it is s giving this reduction, so from v the ultimate will be 0, and it will be standstill such that the bullet stops. That means ultimate velocity is from u, it has reaching to u. So that means the initial velocity v I can take, v is equal to 0. So initial, this is our initial velocity equivalent, this is final velocity equivalent. So my equation will, if I use the same, so again v square is equal to u square, as it is retarding 2a and this case S1. The S1 will be such that it will be multiple of S. So V final is equal to 0, U is equal to that initial velocity V square and 2A S1. Now here I have to write somewhere that A I have received is equal to 1 by 2S into 39 by 400. So that I will use somewhere. So now from here V square is equal to, so S1 is equal to V square by 2A, and along with it will be V square will be there, or 2S, yes, V square will be there because V square is in the calculation. So V square by 2A, if I put the value here 2A, so it will become 1 by S 39 by 400 into V square. So V square will be cancelled out. So this will move on the top. That S and the 400 will be S into 400 will be here, and 39 will be there. So now S against S1 is how much? S1 against S, that means number of plate I will find, because one if it is of S width, so in S1 how many such width I will find, that is I will get from 400 by 39. So it is almost come how many? The number of plates you required. So I have to get the plates, because fractionally plate will be in the all plates. So but in the last plate it will stop somewhere in between, because this is not a perfect multiple of this. If I take it is 40, it's almost 10 plate. So 10 plates have to use, but the last plate the bullet will stop before. Okay, because this is no, sorry, this will be more than 10. So I have to take 11 plates, because 39 if I divide 400, so 39 is a 39, it is 10. So that means then it is 10, that means 10, 39 is 1, 0 will come, so 10 will be there. So the remainder will be for 10. So remainder 10 means I need some fraction of the last plate. So 10 will not be sufficient, because 10 then further bullet have some velocity. So if I use the 11 velocity, but 11 velocity the bullet will stop this fraction, within this fraction of this. The total plate will not be used, or rather one third you can say, 1/3 or 1/4. After 1/4 it will stop, but the number of plate that I have to use is 11 plates. This is the requirement of the sum. Okay. So this is up to this problem. From next problem, that will be chapter 19. I will go to number 33. Thank you.